Now this is how to do it graphically, but we can take a look at how to do it algebraically. So Colin wondered if he could solve the same inequality from example 1 without drawing a graph. In his work, he said x squared plus 2x minus 8 is greater than 0. He factored the quadratic like you would if it was equal to 0 using a factoring method to solve the quadratic, and got x plus 4 and x minus 2. And then he said that x plus 4 is greater than 0 and x minus 2 is greater than 0, or that x is greater than negative 4 and x is greater than 2. Since he said that x has to be both greater than 4 and greater than 2, like when we were dealing with our restrictions in radicals, he said the final solution is that x is just greater than 2. But when I take a look at class example 1, this isn't my full solution. It doesn't cover all the possibilities. Colin's answer is incomplete going from line 2 to line 3 because he concluded that if the product of the two quantities is positive, then both of them have to be positive, but that's not true. So when it says describe the other case that Colin did not consider going from line 2 to line 3, the other possibility is that both quantities the x plus 4 and the x minus 2 could be negative. The product of two negatives is also positive. So if they both happen to be negative, a negative times a negative would make a positive as well. If I take that idea, then I can split off and have a second portion that exists once we get to line 3. I could say, well, what if they were both negative? Then x plus 4 would be less than 0, and x minus 2 would be less than 0, which means that x would be less than negative 4, and x would be less than 2. And if it's both less than 4 and less than 2, then x would be less than negative 4. And that solution region would cover both the possibilities as well. And when I take both those possibilities together, that's going to give me my full solution region. It could all be positive, x is greater than 2, or they could all be negative, x is less than negative 4, and that's my complete solution region. If I'm doing the same process for example 2, then I would say that x squared minus x minus 20 is less than or equal to 0. When I factor it, I get x plus 4 and x minus 5 is less than or equal to 0. How do I get a negative number, or a number that is less than or equal to 0? It's by multiplying a negative and a positive or a number that's less than 0 times a number that's greater than 0. Or the other possibility is I can multiply a positive and a negative. Where x plus 4 is the positive in this case and x minus 5 is the negative. When I solve this, I can say that x is less than or equal to negative 4 and x is greater than or equal to 5. And it can't be less than a negative number and greater than a positive number at the same time, which means that this would give me no solution. It's impossible. Couldn't possibly be less than negative 4 and greater than 5 at the same time. But if the x plus 4 was a positive and x minus 5 was the negative, then x would be greater than or equal to negative 4 and less than 5. And that means that anything in between negative 4 and 5 fits both of those requirements. And there's a solution region that works, which means that the solution is negative 4 is less than or equal to x, which is less than or equal to 5. Now, whether you realize it or not, we actually just did case analysis. We looked at both the possible cases that could exist depending on whether it was going to be a negative number or it was going to be a positive number. So when I have a quadratic inequality where it is greater than or equal to 0, the only way I'm going to get a positive number is either both factors are positive because a positive times a positive is a positive, or both factors are negative because a negative times a negative also makes a positive. When I say that my quadratic inequality is less than or equal to 0, then that means that I have to take a positive times a negative or a negative times a positive. Now, it is not actually a requirement, but I promise you it will make your life infinitely easier if you approach it this way. Look for whether or not it's going to be greater than or equal to 0 or less than or equal to 0 when a or x squared, because it's just your coefficient of x squared, is positive. Now, it is possible to do it the other way, but the problem is, especially if you get into the factoring, most of us don't like to deal with the factoring of negative x squared plus x plus 20. There's something that typically goes wrong when factoring when I have a negative x squared. So it's just going to make your life a lot easier and you're more likely to get the correct solutions. So always try and make your x squared be positive. Let's try this. If I'm using case analysis to solve this, then the first thing that I'm going to do is I'm going to make my x squared positive, and I'm going to move everything to the other side. You don't have to do it, but it typically makes it so that there's less mistakes that happen. So when I do that, then I can say that positive 3x squared plus 14x minus 5 is less than or equal to 0. It's the same as rearranging and multiplying everything by -1. Now the second thing I have to be able to do is I need to be able to factor this down. Well, I mean, if you want, you can find the roots using any other algebraic method that you deem necessary. I'm just going to factor it down using decomposition, and I'm going to say that if I have 3x squared, to get that 14x, it's going to be the same as 15x minus 1x and minus 5 is less than or equal to 0. It's the two numbers that multiply to -15 but add up to +14. I'm going to factor these by grouping and say that if I have 3x and x plus 5, and I take out a -1, I get x plus 5. And finally, I can state that I have x plus 5. Sorry, I wrote plus 4 here. And 3x minus 1 is less than or equal to 0. Now, at this point, for your cases, I'll let you use a number line. You still need to state the two possible cases. So I call it case 1 and case 2. I can create a number line. And I'm going to state the possibilities. If it says that it is less than or equal to 0, then that means that it has to be a negative. How do I get a negative? I can get a negative from a positive times a negative or a negative times a positive. Now, when I solve what these intercepts are from here, I'm going to get the possibility of -5 and 1/3. When it says that this one is a positive, then the lower one is increasing. When it says the bigger one is a negative, that means that it is decreasing. And my solution region is where the two overlap. When I look at case 2, it says my lower one is negative, so it is decreasing. My bigger one is positive, so it is increasing. And there is no overlap that exists in here, which means that my solution is only where there's overlap. The solution is when -5 is less than or equal to x, which is less than or equal to 1/3. If you want, you can do it algebraically, just like we did in the previous two examples as well. All right, go ahead, get some practice.